Okay, so let's solve by graphing. So what are we going to do first? Anybody? Yeah, perfect. Let's write the problems down first. Okay, so I need to graph this line, so I'm going to write this one over here. And then I'm going to graph this line. Let's do this one in green. So I'm going to put this one over here. This line over here. So, first I need to solve for y, because I need this in slope-intercept form. So, to begin, I need to subtract x from both sides. Then I get y equals negative x minus 1. Have I solved for y? Good. So where do I begin? I always begin in the back where b is. So, negative 1 on the y-axis is where I begin. Where do I move? Up 1 and to the left 1. Why do we go to the left, Anthony? Because it's negative. So we always go up, and then we decide whether we're going to go positive on the x or negative on the x. So in this case, we're going to go negative. Now, normally I would just be able to draw my line at this point. But since I'm trying to be really, really specific on where my line is, I'm going to make sure that I draw quite a few points. That way I don't make any mistakes. All right, looks pretty good? All right, let's do the other one. I want to solve for y, so what am I going to do? 1, what do I do? Okay, so we're trying to get rid of the x. It's a negative, so we're going to do the inverse. So what am I going to do? Add x to both sides. So when I add x to both sides, I get 2y equals x plus 4. Have I solved it yet?
Nope.
No, there's still a coefficient here, right? We want to get y all by itself, and 2 is being multiplied by y. So to undo that relationship, we want to divide everything by 2. When I do that, I get y equals, I can't simplify this anymore, so I'm going to pull that fraction out in front of the x plus 2. So I always begin with b in the back. So where am I going to go? How about Cassandra? Up 2, perfect. That's where we're going to begin. And where are we going to move? Oh, I'm sorry. Up 2, thank you. Up 2 and up 1 over 2. Am I going to go in the positive direction or in the negative direction? Positive, good. And let's just do one more point. Up 1 over 2. Draw my line. Not very accurate though, is it? Well, it's not accurate over here, but can we pretty much see exactly where it's crossing there? So my intersection is right here, which means my solution is negative 2, 1. Negative 2, 1. Okay, so let's talk about, based on what you know about lines and intersections, how would you interpret the following and why? So who can tell me which one of these graphs has one solution? Why, Anthony? Good, because it only crosses or intersects once. It intersects right here. It has one solution. Next, raising your hand. Yes, Danielle. Good job. The middle one never crosses. What do we call that set of lines? Parallel. Good job. So obviously, this one is the one that has infinitely many solutions right here. Why does this have infinitely many solutions? Because it has the same line. Exactly. Perfect. Okay, let's look at these. Go ahead and put your pencils down and let's just examine these for a second. I know some of them are hard to see, so we'll just talk about them. So y equals negative x plus 5. I'm sorry, I should explain. Number one is I want you to determine whether each system has no solution, one solution, or infinitely many solutions. So let's look at this one. Negative x plus 5. Let me find that in here. That's right here. That's this line. Let's highlight it. This line right here. And this line, y equals x minus 3, is right here. Does this system have one solution, no solution, or infinite many solutions? One solution, right? It's right there. So we'd say this one has one solution. Okay, let's look at number 2. Change my color. Y equals negative x plus 5. Where is negative x plus 5? Right here. Highlight that with green because we're concentrating on it with green now. And 2x plus 2y equals negative 8. That one's right here. So, does this system of equations have one solution, no solution, or infinitely many solutions? No solution. Why? They never intersect. Because they're called what? Parallel lines. I think you guys have it.